Okay, so yes, we are for man and machine. Symbytech is basically put together out of three things, being symbiosis, synergy, and technology. And we believe that man and machine, all of these elements have a little bit of commonality. So a little bit of inspiration behind the name, hence our slogan. Right, so we basically are a service provider, and we're aiming to, through our environmentally friendly hull cleaning system, to try and help reduce environmental impact that's caused, in this case, primarily by what we call biofouling. So biofouling is pretty much our enemy in this case, and in turn is causing other problems on the hull. And this basically creates an adverse effect, and it has an impact on our environment. So with emissions comes ocean acidification. And in the end of the day, a lot of our livelihoods depend on the oceans, whether directly or indirectly. So we need to look after our planet. As you can see, there is no planet B. So this is the crux of our conversation that I'm going to be having with you today, and why our solution exists. If we don't keep our planet and make our livelihoods viable, then we don't really have much to go for, unfortunately, after this. So in the years past, we used to think that our oceans were vast and deep and big and infinite, and that no matter what we did, we wouldn't really have any concerns around them. The impact wouldn't be noticed. Going back as recently as 1972, people were known to be spewing all sorts of chemicals and toxins and stuff into the ocean, pretty much without impunity. The problem with this, if it's left unabated and uncontrolled, is that we will have virtually no marine life left. And given the fact that the oceans sustain us to such a large extent, this is a key component. So we face a number of different threats as a result of the emissions caused by large volumes of shipping activities. Not only is our planet at risk, but our own health is also a very big component. In the end of the day, we're all stakeholders in this, whether you're looking at it from a commercial point of view or even just the average guy on the street. We all need to breathe, and air is obviously being polluted, as well as our oceans and our food, along with the bios, with the food security, which is coming from invasive species. So in an attempt to try and control all of this, we have many organizations such as the United Nations. We have International Maritime Organization, we have BUMCO, and then we have some of the other projects that has come off from IMO, such as glow filing. In South Africa, we have a number of regulatory bodies, of which SAMSA, for example, is one of them. And many other countries and regions in the world have these more local or national level regulatory bodies that seek to impose a set of standards or guidelines that we can work to, establishing goals. So a number of problems that exist. Reducing greenhouse gas emissions, this is key. We're already seeing a large amount of ice melting with heating that's taking place. A lot of this is not only just by the shipping and the maritime industry, but many other industries which have a similar output to the shipping industry. And this is something that we need to address. On the reducing emissions from vessels. So one of the big problems that you have when it comes to vessel emissions is with biofouling. So whenever a vessel hull is made and designed, it's specifically designed with a certain set of criteria. When you start adding biofouling to it, then it all changes. The vessel gets a higher level of drag to maintain speed, to maintain schedules. It has to basically burn more fuel to try and maintain. And this is where you start having a big problem. So from an environmental component, obviously, yeah, you have the issue with the atmosphere, air pollution, water pollution. And then from a commercial perspective, you're burning more fuel. And this is one of the main incentives that we have for basically trying to incentivize big industry out there to actually use services such as ours and actually make a difference. Now, one of the challenges that you have around services such as ours and others is the ability to avoid any kind of unexpected downtime that you may have with your operations. So as you've already heard with a couple of the presentations before, knowing when things will happen or won't happen or delays or anything like that all has a bearing on operational times and downtime, which in the end of the day, if you're on charter or anything like that, you will have a cost component which is involved. So you want to try and keep this. Our solution, what we're trying to do is basically we're trying to integrate in different levels with people in or with operational companies at different levels and different locations. So it can be in port, can be in anchorage, or it can be an offshore location as well. So yeah, that forms a part of also of our offering better services to maritime companies, enticing them. So the saving, as I mentioned earlier, is a very, very big component on that. We'll cover a bit more of that a little bit later. So what we've basically done is we've adopted the United Nations Sustainable Development Goal 14. And there are 3 particular components in it that we are working towards. So goal 14 is all about life below water. First component is to be able to reduce marine pollution. So in this case, obviously, emissions that go out of the smokestack, these end up landing back into the water, and ocean acidification is one of the main components that takes place here. By reducing these emissions, we can help with protecting and restoring our ecosystems. And then, as I mentioned, ocean acidification is a big component that is the result of one of the smokestack emissions. So our current situation that we have around the world is that 90% of the trade is literally done overseas. Biofiling on our vessels adds 10% additional fuel costs. Some people even say it can go up as high as 30%, depending on the level of biofiling that you have on the vessel. The emissions, as you can see, is around 940 million tons. This was around 2018. I've heard of figures going as high as 1.1 billion tons per year at this stage. So that's about 2.9% of the greenhouse gases emitted by pretty much all industries that's out there. Health is obviously a big component, as I mentioned earlier. An estimated 4.2 million deaths have been caused by it. With regards to hull cleaning activities, divers have been pretty much one of the main activities or people that have been doing these things in the past. Last 40 years recorded about 577 deaths, which is a fairly large amount of money. I mean, sorry, not many people or fatalities. If you give the fact that the industry is actually quite small. It's a very tight-knit and small community. It's not hard to get to know a lot of divers very quickly. In my experience, I've met many. And yeah, 84 of these fatalities were linked directly to hull cleaning activities. So that's a fairly large amount of fatalities that's been linked to this kind of thing. So ultimately, we really want to try and reduce this risk. And then, of course, as I mentioned before, the distribution of invasive species. This is a very, very significant problem because it greatly causes a lot of problems around food security. There's a lot of other industrial problems that they have pretty much on a global level, where, for example, cooling inlets have been found to be more favorable to an invasive species because of the temperature change. They grow there in great number, and they can cause these inlets and outlets to actually block up. So, biofiling, how has it been done in the past? Back in the day, going probably back the furthest, dry docking was probably the most common way of doing it. I remember a story or an image that I saw where they literally had a vessel in a dry dock and they had a bunch of people standing around it in with brushes, and they were scrubbing the hull. So it's not a new problem. Even if you eliminate the newer concerns that we're really pushing towards resolving, biofouling is an age-old problem. So dry docking was pretty much one of the main things that was done. Problem with dry docking in particular is with legislation imposing compulsory dry dock times for vessels at certain periods, there's a lot more vessels than there is dry docks. So there's a large amount of delays. You have to schedule your vessel to be able to get in. You have to work with third parties, for example, scaffolding providers, various other components, and at a cost that is quite phenomenal depending on where you are. In South Africa, you're talking between 10,000 to 100,000 Rand a day just to have your vessel in there, and there's no other activities in it, and you're also not producing. So your revenue is not coming in. Later down the line, diver teams have come in, and they've probably been one of the most common ways of doing biofouling removal or anything, especially when it's in water. As people were incredibly dexterous, and it's relatively simple under good conditions to be able to go and work. However, from a commercial point of view, you require a large team, typically 5 people or more, and they're weather averse. So if you're out in the oceans, you've got currents, you've got swell, you've got various factors, and these definitely have an effect on them. They have a large amount of equipment, so there's a big logistics and cost components attached to it. More recently, as times have become more technically savvy, ROVs have become a more common place to start doing these. Hybrid ROVs have been made specifically for hull cleaning, and they've had a great deal of success, but there's still a large amount of room for them to be able to improve. And they're also affected by similar kind of environmental things, much like divers are. One thing they both have in common is they both are an unstable platform, meaning that they're not attached to the surface that they're working on. So any movement in the water, currents, waves, basically gives them a motion. And this has an effect on the client deliverables and also the quality of the task being done. So we have a solution that we've made. We've been working on this for some time now. And we believe that it has a lot of the other things that previous solutions don't have. We're able to work in high weather. We're magnetically coupled, so you can even put us in on the side of a vessel and we can be in anchorage, waves crashing against it, and the device will stay over there. Because we're stable, we have an improved quality. For the remote component, we have a low persons on board, which is quite critical, especially with the additional work scope that we're capable of. We have a much greater level of efficiency, as we don't have to go and do the job twice. So the device was designed as a single pass device, so we can create a deliverable from what we see in front of us and also what we get at the back in a single movement. We don't have to go back again. The lines that we would follow are pretty accurate, unlike with divers or ROVs that are moved around by environmental components such as swell and current. We're not affected by any of that. Our tracks are dynamic, so they can absorb a certain amount of curvature, so they can take the shape of a vessel's curves. It means that we also have more access to areas that were previously not very accessible by a machine. Divers obviously were not really so much a problem. Time and cost savings. Well, one of the main things here is if you work out any kind of project scope, you normally add in a bit of time for a weather window. Depending on where you are, if you're in port, probably not as relevant. But in terms of being out in anchorage or on site, this is a normal thing you would put in. As I mentioned earlier, we have a high weather tolerance, so we're not really affected much. And therefore, we can cut the project time down, which gives a saving to the client, as well as obviously the fuel savings and the maintenance saving. We're diverless. As I mentioned earlier, we or divers, you have all these fatalities, you have these large teams, there's a big component of risk to personnel. With us, we don't have that greater level of risk. We don't have large teams. Our teams, depending on how you're operating, can be a combination of all remote or local. You're looking at 2 to 3 people to operate the device. We are remote capable, which is a particularly great thing that's coming up. The pandemic has really shown us how the ability to be able to work remotely has a huge advantage. Classification societies are already working with more and more companies that can offer them a remote service, so as to be able to allow them to try and resolve things on the spot. In conventional ways, what you would normally do is you would send out a provisional report to class, they would assess and come back with remedial action or anything else that needs to be done. In this case, you can do everything on the spot. The device is quite small, simple, so rapid mobilization is not a problem to get out to a place quite quick. And then we also have a real-time interaction capability. So as I mentioned, working with class or other remote engineers to have a look at a problem is no longer a problem. I'll show you a little snippet, or actually 3, just for you to enjoy and see. This first one was of a conceptual device that we started off with. Skip on. All right, and this is what it became with our prototype. Just a few images to show you. Just 360 view. All right, so I was mentioning the cameras that you can see in front and behind. So this is what makes single pass tracks have these big magnets built into them. We'll demonstrate that in a moment, and this is what gives us our ability to adhere. So there's a lot of advantage to being close to your surface. In poor visibility, it's often that you still have a short range visual, but in a long range, it's not that great. We work all very much close range. Oh. No, we're going to move on. There we go. Okay. So this is a little explainer. You'll see I was speaking about the magnets, which you'll see in a moment. So these are what give us our adhesion and our ability to be secure on the hull. Also, I mentioned the ability to adjust to contours. And this is one of our payloads that we use. So this is our environmentally friendly hull cleaning component. So basically, it consists out of the crawler with a payload that takes the biofouling off the hull, extracts it through a filter, and then outputs clean water back into the port or into the anchorage area or on site. Biofouling is collected. We're currently looking for some partners who'd be interested in taking the biofouling to make biogas with at this stage. Okay, applications. Primarily from a hull cleaning point of view, the main application is hull cleaning, but the device is quite capable of doing a number of different tasks and activities. Some of them can be done simultaneously with a hull cleaning or other activities. So we're able to provide an inspection. As I said before, you can get your pre and after survey and as well as your cleaning. But in addition, we're able to offer port security, UWILD inspections, so underwater inspections in lieu of dry docking, which works along with classification societies. We can do photogrammetry, which comprises of our machine learning and machine vision. And yeah, we're able to do quite a bit, including pretty accurate measurements. Cathodic protection values we can gain on the fly with most of our abilities, as well as some non-destructive testing, such as ultrasonic thickness, amongst others. Intervention is another component that we cater for. So as I mentioned, environmentally friendly hull cleaning is a part of that component, as well as, for example, discharge cleaning, isolations thereof, sea chest cleaning and isolations thereof. There are a few others as well. We have a data component. So for the clients, in the end of the day, we keep a history. All of their vessel specifics pertaining to activities that we do will be able to be recorded. We'll be able to tell them, for example, when last their cleaning was done, what kind of coatings are on their hull. These are all kind of important when it comes to hull cleaning, because with hull cleaning, you have to know the coating. There is regulation around cleaning and the different types of coating that are on a vessel. Asset management is a big component for companies. They like to know what's going on. If you did an inspection, not all things require immediate action, but they may require an action down the line. And therefore, an asset management is important. And then in the end of the day, deliverables for the client. So what we do is we provide everyone with information pertaining to the activity, and thus they can keep on hand or they can get and review at any time. Markets, maritime, oil and gas, renewable energy, and port and vessel security. Basically, if it has a ferrous hull, we can work on it because our magnets adhere. So whether it's a semi-sub, cargo tanker, a wind mast in a wind farm, or a vessel where we're going in to have a look for port security, whether it's contraband, munitions, structural integrity. These are all areas that we can assist with. So the benefits, there's always two benefits. We've designed our systems and our ways of working to be beneficial to both environment and to the commercial component. So our systems provide a reduction in invasive species, ocean acidification, water pollutants, emissions. These are some of the key environmental adverse things that we have to address and that we aim to address with our systems. We also save our food security. Obviously, if we're not dropping invasive species, we can keep a greater level of food security everywhere. And then the incentives to companies mentioned before is your fuel, your cost of maintenance, and operational costs. So some of the challenges that we've found exist in the industry, I think it's pretty much for most companies, to be honest, but these are some of them. Funding is obviously a big one, especially for a startup like us. Compliance is also a big challenge. For example, we are required to be able to be compliant with various classification companies because a vessel owner or operator would have to be with, say, ABS or DNV. And in the end of the day, our product has to be compliant with the classification societies, ISO standards and others. Permits. So I'm not sure exactly how it works all over the world, but I know in many ports, we are required to have permits, and to get these permits, we have to do a whole lot of activities, including environmental impact assessments. And these need to be done and proven beforehand. Policies, these particularly come through on a national level. Basically, it really depends on, for example, how much a country enforces certain policies. For example, some countries are still permitting rather unregulated environmental hull cleaning type efforts, and others are a lot more stricter on it. So all of these policies have an effect, and you have to meet certain standards. Partnerships is always something that we've based a lot of our connections on, and we've had the greatest success through partnering with different companies and working through with them. And this has also actually solved a lot of our problems pertaining to the market access. So it's a great thing, at least. So in the past, what we've done is we've developed a large network. And this has allowed us to develop our access to market. and basically help us knock down a lot of barriers. Taken on board a lot of key industry advisors and mentors. And amongst others, we ran a survey in early 2020, which I can post the link up for, should anybody be interested in maybe contributing towards it again. And with us, we were looking at finding what the industry needed. So we established a lot of needs and demands. And it's with this in mind that we built our device. The dynamic tracks and the ability to cater for curvature in particular was a requirement to meet need to cater for small vessels. So most hull cleaning companies using robotic style devices can only literally clean side shells, bottom plate, stuff with very little feature on it. Otherwise they start having problems. Whereas we developed a system to get around that. In the past, we completed our proof of concept, and we currently have the prototype which you've seen. So yeah, the rest of the time we're continuously developing partnerships. And yeah, if you feel you've got anything that you could add, you're more than welcome to contact us, and we can see how we could partner with you. So some of the entities that we're particularly looking at for working with is paint manufacturers, shipbuilders, shipyards, agents, sensor providers, educational institutions, which in this case, obviously with MTCC, is a great platform for just that. So hopefully we can establish some more relations there in the future. Our team, small, focused. It's myself as the original founder. I have Eddie Noble, who's joined us as an advisor. He's got 30 years in maritime security in particular. Very much a person known in South African shipping industry. Linton Berger in particular is a very big environmental component. He is in charge of our fundraising in particular. And Daniel Chips, I mentioned earlier, we have a machine learning that we use and machine visuals. It's all part of our AI program, which Daniel heads up. That's it for me. If you have any questions, it would be great. Thank you very much to everyone at MTCC, IMO, SAMHSA, and everybody else who's managed to contribute and afford us this opportunity.